I have a slightly ambivalent relationship with DevOps. As someone who helped to popularise the idea of continuous delivery, I'm sometimes seen as something of a DevOps pioneer, and to some extent I suppose that's correct. As someone who helped to define what continuous delivery really means, though, I confess that I see continuous delivery as the more fundamental concept. DevOps is one of the things that helps us to achieve continuous delivery. I think many DevOps people would see things the other way around, but I think they're wrong. Nevertheless, I think that DevOps is an important movement, and the people that promote it are allies in a common cause of helping us all to build better software faster. Today, I want to explore a core DevOps idea. You build it, you run it. So what does this mean, and what are the practicalities and implications of working this way? Hi, I'm Dave Farley of Continuous Delivery. Welcome to my channel. If you haven't been here before, please do hit subscribe, and if you enjoy the content today, hit like as well. We're extremely fortunate to be sponsored by Equal Experts, Tricentis, Transfic, LaunchDarkly and Roost. All these companies offer products and services that are well aligned with the topics that we discuss on this channel every week. So if you're looking for excellence in continuous delivery and software engineering, click on the links in the description below to check them out. I recently came across this great definition of DevOps from Donovan Brown via a Brian Finster post. I think it really nails it. DevOps is the union of people, process and products to enable continuous delivery of value to our end users. I'd change one word here and replace products with technology, but otherwise this is a great description of DevOps in my opinion. DevOps is a way to achieve continuous delivery. It's not the only way to achieve continuous delivery, but continuous delivery is pretty difficult to achieve without the collaboration that is at the heart of DevOps thinking. DevOps without CD is, in my opinion, pretty meaningless. DevOps is not a role, it's not a technology, and it doesn't define a team. I've talked about some of the dumb uses of the term DevOps before. Continuous delivery is a foundational idea, the goal. DevOps is an important approach to helping us to achieve it. Practically, CD and DevOps each evolved in response to the same set of challenges, and each contributed ideas that reinforce the other. That core idea of the continuous delivery of value to users is an important one. That word continuous implies a time dimension. My preferred description of continuous delivery as an approach is working so that our software is always in a releasable state. But that is a soundbite. There is more to it than that too. A more accurate form of words is probably something more like maintaining our system in a releasable state. It doesn't sound quite as good, but the distinction here is that that idea of maintaining the system in a releasable state. This, at least to me, implies that as well as keeping the system releasable as we build new features, we also need to keep it releasable as circumstances change. That means that we must detect the change in circumstance and be able to understand what it is that we're seeing and react to it by changing the system to make it releasable again. So what do we really mean by releasable? In this context, we mean that our system is technically and functionally correct enough to deliver value to our users. So if demand for our services goes up to the extent that our system crashes all the time, then our system isn't really adding value to our users anymore, so isn't really releasable in any way that makes any practical sense. So as well as knowing that our changes are safe and they do what our users want them to do, we must also be tracking the behaviour of our system in production, in case some outside factors changes our users' experience of our system. We need to work in ways that allow us to respond to changes in production quickly and efficiently so that we can keep our software in that ideal, useful, releasable state. So now we're back to that word continuous again. We want to be able to do this continuously. We need to do this continuously because we don't know when something may change that stops our software being releasable. The most efficient, effective way to keep our system in that state of permanent releasability then is to spot problems early before they develop into a disaster. If we track the usage of our system all the time, if we're lucky, we'll see changes that warn us of an increase in demand. Now we can plot trends and figure out where demand is heading. Sure, we'll certainly get this wrong sometimes, but starting work on increasing the capacity or scalability of our system before that capacity limit is reached is much easier and much better than waiting for the system to collapse beneath unforeseen load. Ultimately, the learning that we gain from the behaviour of our system in production must change what it is that we want to build. So the people that need that information are the people that do the building, the development team. They're best placed to understand the information because they put the measures in place and because they understand how the software works. But even ignoring this fact, purely from the perspective of efficiency, this information coming from production is complex and unpredictable. We don't always have a lot of time to react. So what we'd really like is to keep the development team in the loop. Make sure that they are seeing what is happening live in production. Depending on how your organisation is structured, there may be other people watching this stuff too, but you need to keep the development team informed of the detail of what's really going on and in a position to respond to events as they unfold. I remember working on a production system that was a bit flaky. Periodically, it would go very slow and sometimes even crash. We were working to stabilise it, but for a while it wasn't very stable. I, among others, spent a lot of time watching the logs from the system. This was a heavily loaded system in use by tens of thousands of users, so there were a lot of logs, too much information to be able to really clearly get the complete picture. But after a while, we thought that we were starting to see some patterns that seemed to be correlated with the crashes. We wrote some code to make these patterns clearer, more visible in the logs. Then we attached an alarm to signal when the warning signs were present. Eventually, we found that if we restarted a particular service before it crashed, when these warning signs were apparent, we could reduce the impact on the system overall, so we did that. This is one part, the technical, practical part of the DevOps philosophy of you build it, you run it. The idea is that you want the people that build something to see it in real use. This philosophy and approach has lots of advantages. From the perspective of the development team, it means that they can see their work being used and being of value to users, or at least, as importantly, they can also see when it's not of use to users. This gives them a much stronger sense of ownership for the software that they create, which sounds a bit managerial and corporate, but it also is much more rewarding for those members of the development team to see their software being used and hopefully appreciated. It means that they can iterate on solving problems much more efficiently and much more effectively. In my story earlier, we changed the software to log errors differently so that we could more easily and more reliably detect the precursors of a crash. This kind of interactive work with the production system is really not possible in the same way if everything is being filtered through some different group of people. So the way to minimize delay and increase the clarity and directness of communication is for developers to monitor their systems that they're responsible for in production directly. You build it, you run it. The other aspect of you build it, you run it is perhaps more literal. I still meet development teams who have little or no idea about the production environment that hosts their code. I think that fortunately this is a problem that is gradually receding into the past, but still, this is another important aspect of the DevOps philosophy. The environment in which your software runs is a dependency of your software. That is, if it changes, it can break your software. So there are only two sensible responses to this fact. You either take control of that environment or you code your system defensively so that it's somewhat immune to changes in the host environment. Either way, both of these are development team responses. You can't abdicate responsibility for either of these strategies to someone else. An operations team can't protect your software for you other than by fixing the host environment. And that's a terrible idea. You need to keep your infrastructure up to date to reduce the risk of attack from bad people. Similarly, you can't expect your product owner or sales team to think of and prioritize the technicalities of isolating your mobile or desktop application from operating system or configuration changes. That is a technical job that the development team will be best placed to understand. So in both cases, the development team is once again best placed to be responsible for how the software that they create runs. Software architecture and infrastructure as code are not jobs for people outside of the development team. We need to think about, understand and control the production context in which our software operates. This is to a large extent what differentiates cloud computing from other forms. Cloud services are self-service, they are software driven. Hence the name, infrastructure as code. So we can version control and the definition of the provisioning and configuration of host environments, making them more reproducible, more controllable, and so easier to change. My preference is for development teams to completely own responsibility for defining the production configuration of their own software. Depending on your background, you're probably now either nodding vigorously and saying, of course, how else could this work? Or if you're from a more traditional, larger firm, perhaps you're shaking your head in disbelief and saying, this is crazy, this can't possibly work. Well, if you're in the second camp, then let me assure you that it can and does work. And it works at global scale too. So once again, you build it, you run it, makes an awful lot of sense. The degree to which this idea is contentious, I suppose, is really down to two different aspects. And once again, this is a perspective that is shifting over time, I think, largely because of the impact of cloud approaches to computing. The first problem is that this is a lot of responsibility for dev teams to take on. It seems logical to offload responsibility for some of this stuff to other groups of people. And it is, but most organizations have done this in the wrong way. Building role-based silos is not the correct answer. It places exactly the kind of barriers that we're trying to avoid directly in the path of every, even tiny change. So it's inefficient and tends to increase bureaucracy and reduce rather than enhance collaboration. The team topologies approach is a much better model, giving responsibility for user-facing change to what they call stream-aligned teams, managing the cognitive load of those teams and supporting them with enabling platform and complex subsystem teams. None of these teams are delineated by the technical role or function, really. Any of them may be populated by a mix of people playing different roles. But for all of them, their job is to, via the stream-aligned teams, deliver value to users. This seemingly subtle change in focus is an important one and doesn't mean that the responsibility of a platform or complex subsystem team is passed on to the stream-aligned teams. The team that built those parts of the system too are also responsible for monitoring and running them in production, in the same way that I have already described. You build it, you run it. The other way in which this is contentious is who's responsible for the software if it goes wrong at 3 a.m. in the morning. Well, the real answer is the people that built it. How you cope with this fact will probably depend on where your organization is in its DevOps or continuous delivery journey. This is often a big ask for a development team, though, to be honest, operations teams have treated dealing with out-of-hours outages as a normal part of their job for decades. So why this is different for the people that actually built the software is an open question. Let's be clear about this. No one wants that 3 a.m. call, whatever your job title. The second thing to recognize is that however good your operations team, they have a more limited set of responses available to them to fix problems than the people that developed the software in the first place. So all things being equal, the development team are in a better place to respond to production incidents than anyone else, in terms of their understanding of the system and their ability to respond to whatever problems may happen. So ideally, the dev team are on call for when things go wrong, even if it is 3 a.m. in the morning. If you're a developer, you probably don't fancy being on call. But one of the good things about this, both organisationally and to some extent from a personal perspective, once you've been woken at 3 a.m. to deal with an outage, you're going to be trying an awful lot harder to not be woken up again. So now you have a real sense of the importance of doing a better job. I think that one of the hallmarks of an ideal organisation is that everyone, whatever their job, gets to see the outcomes from their decisions, and in a way that they can respond to those outcomes and correct the less than ideal ones. So if you're on call and are woken at 3 a.m, once you've put a sticking plaster on the problem, make damn sure that once you're back in work the following day or the day after, that you never have to be woken up by that problem again. This puts a pressure on us to build better software. What this DevOps idea is really about is making the responsibilities clear. The people that build the software have a responsibility to do that well. They should apply themselves to do a good job, and having some 3 a.m. skin in the game is a good way of reminding everyone that there's a cost to not doing a good job. But actually, much more important than that, this is also about giving development teams not just a sense of responsibility, but real responsibility for the systems that they produce. And with that sense of responsibility comes a sense of pride in a job well done too. Thank you very much for watching, and if you enjoy my stuff, please do consider supporting our work on this channel by joining our Patreon community.